Good morning, all of you. I hope you're practicing for your physics class 10 exam, which is going to be held on Monday, ICSE. So, today we are going to discuss some important questions from whole syllabus. So, the first question is a person uses a lens of +2 diopter power in his spectacles for correction of his vision. Name the defect of the vision that he is suffering from and determine the focal length. So this part of the chapter is of chapter 5 and it is given under the application of the lens. So do make sure that you just once read the application of the lens. So power is given to us because the power is given in positive. So we know positive means a person is suffering from hypermetropia. Hypermetropia means the person can see only far away objects easily, whereas the nearby object the person will face problem. And one more thing here, plus means that you are using a convex lens. So let's find out the power is already given to us 1 upon focal length, and we know this f has to be in meter. Now next is when you are going to put value, that is 2 is equal to 1 by f, interchange, f is going to come 1 by 2, which is 0.5 meter. Either you can leave your answer in 0.5 meter or you can convert it in centimeter. How? By multiplying this by 100. So your answer will be 50 centimeter. And now they are saying to determine the focal length of the lens use, that we have done. So focal length is 50 centimeter. Next question is, where would you place an object in front of the convex lens in order to produce a, first part, real magnified image? So this is the diagram that I have drawn for here. So the question is saying that you need a real magnified image. So real magnified image, magnified means the size should be greater than that of the object, and we know in the last case, that is when you place your object between f1 and optical center, here somewhere here you get a, sorry, here when you place it between f1 and o, you're going to get a virtual and a magnified image, but the question is saying that you need a real and a magnified image. So for real and magnified image, if we are going to place our object between 2f1 and f1, somewhere in between this distance, we get our image beyond 2f2, and we know when the object is image is beyond 2f2, it is highly magnified. So the answer for the first part would be, that it should be placed in between 2f1 and f1. Next question is an image of the same size as the object is. So here we know if we place our object at 2f1, we are going to get our image at 2f2, and that will be of exactly same size, but the difference would be that it would be again real and inverted. So the characteristics would be real, inverted, and it would be of same size as object is. Next is an erect magnified image. See, it's very clearly mentioned erect. When we say erect, it means we are talking about virtual image, and we know only in one case that is possible where you are going to get a virtual image in case of convex lens, and that is when you place your object between f1 and o. So when you are going to place here, you are going to get image somewhere on this side, and you are going to get a highly magnified image, but that would be erect. Erect means it is going to be upright. Okay, after that, the next question is, why is it possible to focus clearly on object underwater when your eyes are underwater if you wear goggles with plain glass in them but not with the naked eyes? We all of us know that if you want to go underwater, you cannot go without wearing any safety glasses. We have to wear glasses, and that is basically the plain glass that we wear. So they're asking what is the reason. So of course this part is again from the refractive index part, right? So you will say here that when you are wearing goggles, so the goggles, the gap between your eye and the goggle, there is in between, there is air, right? So when the light is going to enter the goggle, what will happen? It is going to refract the light properly. I'm repeating again. So when you wear a goggle, what happens? We are creating a small gap between our eye and the goggle, which would be air. And when the light is going to enter, what will happen? It is going to refract properly. And what will happen if you don't wear it? So what will happen? The refractive index of our cornea and that of our you can say water, that would be almost same. So what will happen? The image will appear to be blurry. So why do we wear it? So that we are able to maintain proper refractive index between the water and our cornea of the eye. So that is the answer for 14th question. Next is name the phenomena responsible for. First is twinkling of stars. So that we all of us know that is because of the refraction of light. Second part, upper surface of water contained in a beaker and held above the eye level appears like a mirror. So whenever you are going to find something very silvery, shiny, like this, like a mirror, so you will say that it is because of the TIR, total internal reflection. Third part will be also same, that is crack in a glass window pane appears to be silvery. So again the reason would be TIR, total internal reflection. Next question is 16th. What do you mean by the term refractive index of water is 1.33? So we know refractive index formula. If we know the formula, we know that mu is equal to C by V. What is C? C is the velocity of light and V is the velocity of C is the velocity of light in vacuum, V is the velocity of light in a particular medium. Okay, now they are saying the refractive index of water is 1.33. It means that when the light is going to travel from air to water, so the speed of light is going to decrease by 1.33 times. I'm repeating. It means that when the light is going to come from air to water, so because the value is 1.33, it means the speed of light is going to decrease by 1.33 times in water. So if suppose they ask you what about diamond, so you are going to say the speed of light is going to decrease by 2.61 times in diamond compared to that in air, right? Next is, to a fish in water looking at a plant outside the water, the plant appears taller than its actual height. Okay, suppose they ask you what is the reason, so you will say the reason is refraction, because we know when the light travels in two different mediums, the speed of the light changes and the direction also changes. Draw to explain the diagram. So here I have already drawn the diagram, this one. So fish is taken underwater and you're going to draw two rays, and make sure when you're drawing two rays, don't draw the ray to be normal, because we mostly don't consider a normal ray. So you have to draw two oblique rays so that we can get the image of the object. So now here the plant is still here, right? Now what will happen if you, okay, so here if you will see, the ray will go straight, it would have gone straight, but the thing is because of the refraction it will go away from the normal. I think this is not correct. Away would have been somewhere, this you, I'm showing it towards the normal, it should have been away somewhere here. Okay, and similarly when you are going to take the other ray, so again it would have traveled straight, but it will go away from the normal. So going away from the normal, you are going to join the two rays, and wherever they are going to meet, there would be the image formation. Here in this case, you are going to get your rays at a point above the plant. So to the fish, actual height of the plant is this much, but to the fish it is going to appear of this much size. So why this much difference is there? It is due to the refraction of light, because of which the size appears to be taller to the fish. And similarly they can ask you one more thing. Suppose they ask you that a person is standing outside water and to that person the fish appear to be shallower. So the reason would be same, that is because of the refraction, and then you have to draw the diagram. These diagrams are given in your Selena's book, right, where you are reading the topic apparent depth and real depth. So there, instead of that object they have drawn a dot, real and apparent. So from there you can prepare. This is one of the important questions. Next is, this is very important because this was in one of the specimen papers, but this question didn't turn up in the board exam. So yes, graphical part is important. So the question is, okay, so the question is, the graph is given to you. This is the graph, and from the given graph you have to find what is value of delta minimum, and second you have to find what is angle of prism. Almost everybody would be able to do part first, because from here you have to read the graph, and we know this is delta versus I graph, and the graph where it gets the minimum value, that respective value is the value of delta minimum. So answer for the first part would be 20, and if they ask you what is the value of incidence with respect to delta minimum, so that would be 35. Now next is find the angle of prism. This question could be little different, or maybe you think that many values are not given. So how we are going to do that? So here what you can do is, you know these values. You know at 30, delta 30, you have two values. One is 25, this is 25, and other is 45. So here one thing you have to remember, at two delta value, I mean at single delta value, you have two different values. What does that mean? Means if this is angle of incidence, then the angle of emergence you will take it to be 45. Remember this fact. Or one thing more is that if suppose you take this to be your angle of incidence, that is 45, so with respect to 45 your angle of emergence would be 25. This you have to remember. So at, but only at 20 degree, what will happen, your I and E value, they will become same, that is 35. So you have done it. When we place a prism at minimum deviation position, what happens, I and E value, they become same. So at minimum deviation position, that is at 20 degree, you have I and E to be equal, that is 35. But when it is other than this value, that is when it is other than 20, you will always find two values of I, that is one, suppose you are taking 30, so here you have 25 and one you have 45. So what does it means, at 30 degree of delta you are going to get I to be 25 and E to be 45, or you can also say that this value would be, this could be I and this could be E. So let us write the formula, that is I plus E is equal to A plus delta I. Okay, so if suppose I am taking I to be 25, so my E would be 45, because at same delta you have two values here. Okay, so I'll write 25 plus 45, right? That is equal to A I have to find, and delta is 30. So what we are going to do, you just solve it. So you're going to get 0, 60, 70 minus 30. So A, angle of prism is 40 degree. This point is very important, that you should know how to find the value of I and E from single delta, right? So at minimum deviation value, you will have same value of I and E. That is why you're getting a single value, that is 35. But when you have got, say, other values, say that is 30 degrees, so you'll have two values of the graph, means you can see this graph is having two values at the same time. So one value would be of I, one would be of E, right? So I hope this is clear, and I'm going to upload few more questions for practice. Do watch them out and practice, and all the very best for your exam.